Mr. Ondřej Synek and Mr. Tomáš Molek, both from Unicorn.
Thank you very much. So I hope you can see my screen and everything works fine. And I would like to talk now about the tool for the aggregator of flexibility. So let's look on the agenda, what will be my presentation about. And as you can see, firstly, I would like to talk about a digital twin for the flexibility aggregator. So it means what are the key requirements and how to transfer the business of the flexibility aggregator from the real world to the IT world, to describe it in the technical and IT way, and how everything is related to providing of the flexibility and balancing services to, for example, TSOs and the DSOs. Then I would like to also touch briefly the future challenges for the flexibility as we can see it in Unicorn. And then I would like to hand over my word to Ondřej Synek, who is our specialist for e-mobility, and we can discuss, or he will explain to us how e-mobility and charging stations could serve as a source of the flexibility. So that's about mainly dynamic load balancing, and it will be his part of the presentation. So, but let's start with the very basics, and these are from the aggregators flexibility point of view, and virtual power plants, which is a term known for kind of long time. But for example, 10 years ago when I started at the university, it was something what I thought it is a really far away future, and it was difficult to imagine for me that here, even in Czech Republic, will have such kind of possibility to have distributed energy resources serving as provider also for balancing services also, and the output levels like 10 of kilowatts or 100 of kilowatts. And nowadays it's a reality. It's, from my point of view, it's really amazing that we in quite short time we make such a huge progress on the IT side and legislation side and technical side, that now we are able here also in the Czech Republic to provide such as services, for example, to transmission system operators. And you can see that there are multiple resources, and all things have to work together properly, and it is not possible without the proper IT system in behind of such flexibility aggregator. So that's the cornerstone of every business of each flexibility aggregator, that it needs some strong IT system which will help all to drive and to run all his processes efficiently and with as much failures and mistakes as possible. So what are the key requirements and specifications for, let's say, such a tool, such a software for flexibility provider? It's important to realize that each flexibility provider tries to constantly and continuously looking for the flexibility in its own portfolio, and the sum of individual flexibility of individual assets. So it means how fast they can respond and how they are available for usage is much higher than if we sum this flexibility as for a whole portfolio, because as you can see here on the graphs, there are different realms of individual assets for consumption assets or for production assets, and each asset can help, or the faster assets can help the slower ones to achieve the required RAM for example, given products or given services which are needed from the market. So if you do some actions or business and trying to find the flexibility above your portfolio as such, not do it individually, source by source, you then realize that you have much more flexibility than if you sum all the individual flexibilities for each asset. What is also very important is that if you have real-time data, and you need to have real-time data for proper way of the system, because you still every second you need to know what are the status of each asset. So it's really very crucial for the system, for the software, to have access to real-time data, and it's also very important to be able to work with the data and do the right calculations about this data. And also it's related to some estimations and forecasts and predictions, not only about the production and consumption, but also to other values, like, for example, prices on the markets, like weather or like system imbalance, and etc. There are a lot of things that need to be estimated or predicted for correct, let's say, behavior of a whole portfolio, and for making the right business decisions. Then it's very also important to have some optimizations above this individual assets and how they are individually operated, and how to, let's say, work with their ramps and with their ramping. And it's let's say very real-time action, and you need to have a software which is capable to be able to for example, immediately switch from one asset which for some reason breaks down to another which is for example in some hot standby mode, and to say hand over the work of the one which is somehow defected, because you can have tens or hundreds or even more assets in your portfolio, and it's kind of a regular situation that some assets fails or have some failure, and then it's really necessary to replace such an asset as fast as possible. Then what is also really important is to have some kind of tool which is capable to give you the correct and optimal strategy for bidding for different markets. And because the market units are shorter and shorter now, we are heading towards 15 minutes, and it will be in the future probably even less. So it's again very important to have some tool which is able to make the calculation very fast and make the optimization outcomes to deliver them very quickly. What are some other really necessary things, for example, are the capability or the ability of the system to model, to have some space for simulation, the behavior of the portfolio. For example, when you need or where you would like to try to adding a new asset, and how the portfolio behavior will change when the new asset will be, or some new group of assets will be part of your portfolio. It's again important for some strategic decision, whether you would like to have some relationship as aggregator with some new customer, whether you would like to include the new assets to your portfolio, whether it makes sense for you economically to add this new assets to your portfolio. And what else is, from my point of view, very interesting is the control system. Is the heart of a whole software tool, because without this control system, it's not possible, or without proper function of this control system, it's even impossible to deliver all the energy that you have traded properly, and it will be very difficult to operate on the market. So let's look on how we solve this, let's say, software tool for aggregator in Unicorn. We, for such purposes, have products called Flexigy. And you can see here, it's a business decomposition, how we see it's functional from business point of view. And as you can see, there are mainly 5 most important modules, and in the heart of everything sits the optimization module, which is the key part again of the system together with the control system, because optimization module gathers the inputs from the business and operational point of view, and do the calculation and do the optimization, and the outcome of the optimization is the optimal allocation of resources to the trades that have been made, and also the bidding strategy for individual markets. So how much megawatts you have available and where to put it, and for how price, what should be the price for such offers to individual markets. So that's really the key part. And as you can see, there is also a lot of integration to external systems of TSO, DSO, or some market operators. It's quite varies from state to state, obviously. But for example, here in Czech Republic, we have now need to be integrated to the DSO, because there will be information from DSO side to whether the grid is available for given asset. So you need to load the availability of the grid for the asset. You need to communicate with the market management system of transmission system operator to place your bids, and to get the information about the acceptance of the bids. For example, for balancing services, you have to, as as a flexibility provider aggregator, you need to also do the trades on daily or intraday markets, and to be able to take care of your market position. You also need some ETRM software. And at the end of the day, we also need to apply all the operational schedules, which are outcomes of the optimization, to the control system, and to drive in every quarter hour and every, let's say, every second. You need to tell the individual assets how they should work, and they should how they should run according to your plans, and according to trades that have been made, or according to the signals which are coming from TSO. So it's a really kind of complex system, which is very well defined and designed. And we can see also here now in Czech Republic that a lot of parties are interested in this kind of system. And for example, yesterday there is, or 2 days ago, in the news, information about the 2 new official aggregators were introduced on the Czech market, and we are in talks with some others, and we know that some others will join in a very short time. So it's a really very interesting field here in Czech Republic. And we can also look on this our product Flexigy from, let's say, more IT point of view. It's my next slide. where we have kind of depicted how this system could look like from the IT point of view. So here we are now talking more about the digital twin for the aggregators, as I mentioned at the beginning. And you can see that there are some business module or some modules which are similar to the business one, but we have here some additional functionalities like interfaces and our energy gateway, which helps us to communicate with external worlds. We have some shared services like identity management or auditing, which are also essential part of our architecture in general. And we also have the ability to run our platform, our Flexigy product, at least partially, on the classic cloud environment. And as we can see, for example, for a control system, the cloud deployment is not so efficient because of the timing and the need for real-time communication. So it's more about the on-premise, let's say, deployment for such part of the system. But in general, the system is very modular. We can, let's say, use only some kind of modules which are needed by the client. We don't have to deploy all the sub-application or the subsystems. So it's very likely that some client already have some control system or has its own optimization. So we are able only to deploy or to deliver to him only the subsystems from our Flexigy product, which are needed or which are requested as a complementary solution for already existing one. So if I would sum up our Flexigy product, we provide a comprehensive solution from both business and technical point of view to manage the virtual power plant portfolio. And it's suitable for both existing and also emerging market players because it's kind of a different attitude from both types of clients, whether it's existing one, then there is some kind of different needs. For example, when there is already some provider of balancing services to TSO and he only needs to enlarge its portfolio to some smaller assets, it's very likely that he has already some existing IT system which needs to be only enlarged by let's say our systems or by our sub applications. But if there is completely new market player which has the asset but has no experience with trading and with managing the virtual power plant for balancing service purposes, for example, then you need to deliver to him the whole solution as such, very likely. So the Flexigy can continuously identify the flexibility in the portfolio and it's responsible for its monetization. It's optimize the schedules and it's take care of the real-time asset dispatch, and as I mentioned, it helps to determine the optimal bidding strategy across not only balancing but also the other markets like intraday or day ahead, or even to help with the balancing of own portfolio and taking care of own imbalance of the Flexibility aggregator. And what is very important is that it's also our product is also ready to be used for standard products for balancing, which are now being implemented via pan-European platforms like, for example, Terra, Mari, or Picasso. And here it's our, let's say, logo. You can, it's our world premiere of logo for our product. So it's this is it, and I hope we will see this logo as a label on some products for deals that we are currently in talk with, and yeah, that's it. So then, as I mentioned at the beginning, I would like to talk more about the integrations and about stuff how the flexibility aggregation is difficult to incorporate into existing environment, and what are the key challenges for its implementation from integration point of view. As I've already touched the topic of DSO, I think it's not needed to repeat it. So I would like to more talk about the TSO point of view and how the flexibility aggregators will interact with the external world, especially from TSO point of view. So it's important to understand that flexibility aggregators can be also international companies, but it has to, let's say, from TSO point of view, still be national wise structured. So it means that in each country you have to have your integration to local TSO. It's not possible to have it some kind of one standard international integration, but you need to integrate on the local markets where each TSO operates and where you have the assets. And then it's very similar. Then it's because of the standardization, you just need to respect the technical and economical limits of individual assets, and you just use them for the standards products which are defined by the INSOE and the TSO, let's say, standard platforms like Mari or Terra. Here it's important to know that the granularity of such products is 1 megawatt, and to effectively use the flexibility, it's very important to, let's say, have some tool which helps you to identify where it's efficient to use, on which market is efficient to use your flexibility. And what is very also interesting and important is to use the possibility or the features of the new balancing platforms, like a possibility of linking the bits within the portfolio within one market time unit, within 1 quarter hour, or even across multiple quarter hours. So then you are able to create a better and use more flexibility in the portfolio when you are using such options of the platforms. But as I mentioned, it's important to have the integration for the local TSO. And I'm slowly going to the end of my presentation, where I highlighted some challenges in regards of the flexibility, especially here in the Czech Republic. We are now in the phase that we have so-called integrated aggregators. So it's not some independent market entity, but aggregators needs to be integrated into some party which is responsible for its imbalance, and it's very likely that in a few years we will have here in Czech Republic this independent aggregators, that it will be possible to split the role of the company which trades with the energy and delivers the energy to the final consumers, and to have the independent aggregators here. And also we would like to implement then the features for these independent aggregators to our product Flexigy. What is also very important, and especially here in Czech Republic, it's now very actual topic. It's the need for new marketplaces where new services, for example, especially for DSO, can be traded. We are here in Unicorn again involved in some pilot projects where some kind of proof of concept of such marketplaces being tested with Czech DSOs and TSO and also flexibility providers. So this will be again some future very important challenge to get or to reach the point where such flexibility market place also on the DSO level will be in place. And there are some other challenges, for example, community-based virtual power plants or the sharing of the energy, let's say on the level of individual consumers. Again, that's something that we are very close to with some of our projects, and we see a very interesting future for this type of system, which will helps to share the energy between the individual consumers. And last 2 points that I've highlighted here is the blockchain technology usage, not only in the energy domain, but especially for the flexibility purposes. And it's again connected to the previous point of community-based virtual power plants, where it's possible, let's say, to replace the central authority via this distributed blockchain technology, and it helps to, let's say, use some kind of platform for sharing the energy between the consumers. And not least thing is to allow the e-mobility and the charging infrastructure be part of the flexibility. We are thinking about this very deeply, and that's why also Ondřej Synek, my colleague, is here with his project Charge Up and product, and he would like to talk more about dynamic load balancing. So I think I reached the end of my presentation, or my part of the presentation, and now I would like to hand over the word to Ondřej.
Okay, thank you, Tom, and thanks University for inviting me to this conference. As mentioned, I will be talking about e-mobility as a part of flexibility market, and it's quite simple because e-mobility is a very good candidate to become a vital part of this market, since the electric vehicles can be charged and discharged, as well as the performance of charging stations can be managed in both directions. For that reason, I would like to introduce you Charge Up, this partially, which is our comprehensive solution for e-mobility, consisting of both hardware and software. And I will focus on load balancing, which is the essential part of everything. Let's go to the next slide, please. I'm sure that you know that e-mobility is ramping up quite a lot over the few last years. This is caused mainly by the restrictions coming from Europe and the pressure on making mobility more fossil-free. But in general, we expect that the electricity demand will increase, and this will bring some impacts on distribution and transmission grids. These impacts will be represented by more disbalances. Therefore, proper energy management and load balancing is absolutely necessary. It is also important to make sure that charging infrastructure will be able to communicate with the vehicles as well as with the grids. Let's go to the next slide, please. There are basically three essential things enabling efficient load balancing in e-mobility. So the first one, it's intelligent management of charging station provided typically by some software solutions I will talk about later on, integration of charging infrastructure and the grid, and last but not least, standardized communication between infrastructure and electric vehicles, as well as with power grids. With that, it's really possible to manage the performance of charging stations in the way that the consumption will stay in the desired level and in the balance. Not mentioning that it's absolutely vital to have load balancing for flexibility market presence. Let's continue, please. There are three basic types of load balancing. The first one, that's the proprietary solutions such as HDO switch, that's Czech abbreviation for remote mass control, sockets with timers, that's typically present in households and retail, but there are also smart wall boxes which can be set. Limits in these wall boxes can be set via the app application or directly within the firmware. This is not very appropriate for the installations of high number of charging points. Another one are local energy solutions such as local smart grids, energy storage facilities. In general, balancing here is provided by some hardware components which are communicating with the charging stations, such as power regulators. The master-slave concept is also very common here. It means that there is one master station communicating with the regulator, while the other stations, the slaves, are connected to the master and following the commands. This is a very, very cost-efficient solution. The third and most advanced type of load balancing are the central management systems. And when we go to the next slide, I will tell you how we approach this field, because we have developed our central management system under ChargeUp brand. It's called ChargeUp CPO, and as you can see on the left side of the screen, the ChargeUp CPO covers many features except of the load balancing. So dispatchers and operators are using this tool for managing the charging portfolios, for the remote control and management of the charging stations. They are notified or alarmed anytime something unexpected happens. This solution is actually responsible for giving the rights to the end customers who can charge, who not. And also in case of commercial charging services, this is the tool within which you can set or work with your customers, with their cards, with their tariffs, and many more. Of course, there are some reporting capabilities on top of that. What you can see on the right side, just very briefly, that's ChargeUp ESP, our end-user mobile application, which is designed for e-mobility drivers to easily find, localize, use charging station, pay for that cashless by card, and get the payment received. This is a very good alternative to charging cards or RFID tokens, which are pretty common in the e-mobility world. On top of everything, there you can see the set of services we provide together with ChargeUp. It's mainly about the support of end users and users of the system. We provide 24/7 help-desk support to all kinds of users to provide a smooth operation and also proactive monitoring of charging stations. Therefore, we typically identify and resolve problems even before our end customers or customers of our customers even notice. So let's go to the next slide, where I would focus on load balancing. This is a feature which can be divided further on static and dynamic load balancing. The static load balancing means that you have set the fixed limits, power limits for individual charging stations, which cannot be changed later on. And dynamic load balancing is basically about these individual limits changing in time. And because a lot of aspects are going into this game, we are typically integrating the CPO also with third-party solutions, third-party services or systems such as energy management system of the building, which communicates in the near to real time and giving us the consumption data based on which we know what's the available capacity in every single second. And based on that, we are telling the charging stations what power can be distributed between the available charging stations. There are also decision rules, other algorithms, or combination of both. When we continue to the next slide, I believe this is the moment when I will take the screen for a minute, because I want to show you how such a solution looks like in practice. So what you can see on the screen now is the welcome screen of ChargeUp CPO, our central management system. And I can go directly from here to the specific charging points according to the status, but I can go also through the menu, which is actually in Czech. I'm sorry for that, forgot. I can go through the menu to the list of charging stations, to the customers I serve, to tariffs, which can be defined as for consumption or time spent with charging. I can go to transaction history. I can get some reports out of the systems. Here are the alarms I was talking about, very important thing. And last but not least, the communication log, which saves all the communications between the system and the stations. When I go to the list of charging stations, there are 5 stations I have in my system, while 2 of these are online and up and running. The first one has 3 charging points. The second one has 2 charging points. While these 2 charging points are currently occupied, you can see that someone is charging on these points. So we can take a look on the energy node, which is aggregating these 2 charging stations together. It's called Garage. And here you can see actually what I was talking about when explaining what is the dynamic load balancing about, because here I have the maximum power limit set for this node, Garage, 40 kilowatts, while these 2 charging stations both have 50 kilowatts limits, together 100 kilowatts limit. But the system takes care of that the stations will never reach 40 kilowatts. And you can see it also here in the transaction list, because these 2 transactions are actually these live transactions, as you can see in this blue indication. And you can see that first transaction is limited by the system to 27.778 kilowatts. And the second transaction is limited to 12 and something to that. So in total, it's 40 kilowatts. And this is the value which can be taken from the external party, from the third party system, from the energy management system, or which can be also set up manually by the operator, which I did yesterday at 7 o'clock, as you can see here. So I could continue because this is quite interesting system, and I believe that you will be very, very impressed with what it does. But since it's 4 o'clock and Friday afternoon, I would like to thank you for your attention and leave me a message if you are interested in further detail. Now back to the studio.
So thank you. Thank you for a nice presentation, including this live demo. And since you are the brave last presenters, you still deserve some question, right? Because even though we are slightly over time, so yeah, please, my colleague.
Yeah, but I will have one question to you, Ondřej, because the Tomáš part was pretty exhaustive. I think it's becoming quite obvious that that the mobility is or will be even more significant source of the flexibility. But you have to have a certain critical amount, I would say, of the stations, of the critical or the charging infrastructure, sorry, to make it work somehow. By the way, I have heard that we have won recently a tender for the city of Göteborg in Sweden for more than 1,000 charging stations that we will be managing by our software. Are you able actually to gain the flexibility from the field? Because I could imagine that there is a vast variety of these charging stations, types and producers, etc. So is there some standard already, or is it still sort of the Wild West situation here?
Yeah, actually, it is a little bit Wild West, but overall there is a standard. From the very beginning, we are trying to make our solution as universal as possible, and we decided hence to utilize the OCPP protocol. It's Open Charge Point Protocol, which is developed and maintained by Open Charge Alliance, and defined the standard communication between the CPO or central management systems and the stations. At this moment, we have implemented all the versions of this protocol from 1.5 higher, meaning that we are compatible with, I would say, 95% of charging station producers worldwide. So I think that this is quite universal and we are ready for that.
Okay, I see. Thank you very much for the answers. Thank you very much for your presentations, gentlemen. Enjoy the weekend.
Cool.
Thank you.
Thank you. Bye.
Thanks.